In this module, from the narration of the CMGPD training guide, I'm going to talk about how we went from the original registers, the 8 banner registers that were held in the archives, to the database that we analyze. Along the way, we'll talk a little bit about how certain features of the original data have implications for the way analysis is done, how variables are created, and so forth. The registers from which we produced the CMGPD-LN were originally held in the Liaoning Provincial Archives. They were registers produced by the 8 banner system. The institutional context and the history of the registers are described in a lot of detail in the user guide, and then also in a book that we co-authored with Professors Dingyi Zhuang and Guo Songyi in Chinese on the sort of institutional history and the settlement of this region. Maybe the key point is that the registers, when they were compiled in the 18th and 19th centuries, were intended to track the hereditary tenants on land that was owned by the state in Liaoning. The region was settled in resettled in the late 17th century, beginning of the 18th century, mainly by people moving upward from Shandong province. Some of those people became just private farmers and are not covered by any register. Some of them ended up as tenants on land that was owned by the state and administered under the 8 banner system, or in some cases they ended up in sort of specialized populations that had specific kinds of responsibilities for production. And it's those people and their descendants that are covered in the registers. So the state maintained these registers because it wanted to essentially keep track of the people on its land. Meanwhile, people had some interest in having themselves recorded in these registers because the status of tenant on the state land, it was hereditary, and it carried some perks. Again, please see the user guide and then other sources for additional detail. Now, these registers in the Liaoning Provincial Archives were microfilmed and then archived by Family Search, formerly known as the Genealogical Society of Utah. Very early on in the 1980s, early 1990s, Professor James Lee actually obtained microfilms for some of the first administrative populations that we coded, including Dawi, Gaizhou, and I think Dami, directly from the Liaoning Provincial Archives. For the 26 other populations that we coded, we either obtained microfilms or scans directly from Family Search. Then the images from the microfilm were digital images were provided to the coders in China, and they transcribed the contents of these images to Excel spreadsheets. It was a fairly straightforward process, as we'll see, of when coding a new administrative population. The first register in a series took some time, but then to produce the remaining registers, spreadsheets for the remaining registers in the series, it was a matter of copying a sort of spreadsheet over and then updating based on the contents of the new register, and then linking each record in the new register to that individual's record in the previous register was fairly straightforward. The CMGPD-LN, to produce that from the registers that the coders transcribed in the spreadsheets, we then, after we received the spreadsheets from the coders, we had programs written in Stata that imported the spreadsheets and then concatenated them, sort of used the links carried out by the coders to connect people across registers, and then we had programs to check for inconsistencies across the registers. These programs generated reports that were sent back to the coders for cleaning. So there are basically two types of errors that these sorts of the cleaning process would reveal. One is that in some cases the original registers had inconsistencies. People's ages changed in inexplicable ways between two registers, things like that. Our basic principle was to essentially transcribe the original registers as is. So if we did discover an inconsistency in the original register, we sort of kept it that way in the transcription, and then sort of maybe flagged it, or in other ways dealt with it later in during the analysis with the software. We basically, as much as possible, we wanted the transcribed version of the data to be sort of pristine in terms of representing what was in the raw data, and we didn't want to introduce judgment calls, etc., into the transcription. We'll talk a bit about that later. Now, in other cases, it turned out these error reports revealed that there were typos by the coders, keying errors, things like that. And of course, the coders would fix those and resend the spreadsheets, and then we would rerun the programs. Once we had the concatenated spreadsheets in a Stata file, then we also had the Stata programs to link, kin, and generate variables for analysis. So linkage of the same individual in successive registers was very straightforward. Talk a little bit about that later. Basically, once we connected a person's observations or records in successive registers, we could assign them a common ID. Then we could link children to parents based on their relationship. I'll talk about that later. And then we could reconstruct pedigrees. Now, in the original data, the original data come in two different formats. Before 1789, individuals were listed together in administrative units called ihu, or household groups, that actually consisted of several related households. And these generally, if you see the original registers, they look fairly messy. Individuals were listed in a sort of big group, and their recorded relationship was simply to the head of the ihu. And of course, since an ihu might consist of multiple households, 30, 40, 50 people in some cases, some of these relationships were fairly complex. And again, individuals were listed one after another. Quite often, the address was not recorded, and so forth. But then in 1789, the system was sort of reorganized, and the registers become much more systematic. Registers grouped individuals by ihu, that is household group, but then within ihu, they sort of divided them by residential household. Linghu, people were listed one to a column. They were listed right to left in order of seniority within the household, and the recorded relationship was to the head of the household. In the original data, there's sort of basic common elements. Every person has a relationship to the head of the household recorded. Before 1789, it's a relationship to the head of the ihu. Adult males have an official position, title, or status. If they don't really have anything special, they're typically just listed as a Zhuangding, a healthy adult male, or in some cases Fei Ding, disabled adult male, or if they're older, they might be listed as a Lao Ding, older adult male, or Tui Ding for retired adult male. There's a name in the original data. Typically, young men, boys, might have a sort of simple naming recorded, not their full name with surname, and then but typically men, especially once they married, or especially if they acquired an official status, they might have a more dignified name recorded, including a surname and then a given name. Married women typically only had a maiden name recorded. Daughters typically had very simple names. There are a few cases of more elaborate names, but again, daughters typically just had very simple names. You have the zodiac year of birth, 12 calendar years, animal zodiac, the age and sway, the birth date. In the late 19th century, pardon me, the late 18th century, early 19th century. The birth date appears to be recorded perhaps reliably. If you look at distributions of month and so forth, they look reasonable. But after the early 19th century, the birth dates look very poorly recorded. You see a lot of repetition and so forth. Then we have annotations of events, mostly exits that have occurred since the last register, so deaths, illegal escapes, legal out-migrations, not too many of those. Actually, not many illegal escapes either, but they are recorded. Out-marriage of daughters and out-remarriage of widows. Typically, widows that remarried out, we've done studies of that, typically younger, typically with no children. It was fairly unusual for a older woman, especially a woman with sons, to remarry if she was widowed. Household heads had the names of their father and grandfather recorded, and we haven't done much with that. Here is an example of an original register page from Dawi in 1816. So here on the right, we have this rightmost column indicates that these people lived in the sort of Dawi Tun administrative area. The Swoshu Gutun means that that's sort of referring to the administrative kind of area, not the specific village. But then in the next column, we have an indicator that they were in the plain yellow banner, in actually living in Dawi Tun. There might be other villages that were under the Dawi Tun sort of administrative area, but these people were actually living in Dawi Tun. And there might be other households elsewhere in the register that were associated with other banners. This is, again, the Zhenghuangqi, the plain yellow. There were other, perhaps in the same location, there might have been people in the plain blue, bordered yellow, etc. Here, the first entry here is you have a beginning of a new ihu, and then that is a household group, then a residential household within the ihu, a retired baizong, it's a fairly high status position, named Zhao Wanfa. He's 45 years old. Let's see, he was born in the year of the dragon, in the second month, 11th day. That's lunar, obviously. And then one of the branches. Then this is his father and his grandfather. Here's his wife, surname Ma. She's 40. And then there's some information about her birth. And then their son, who is now 16. And he, let's see, anything not that much of interest here. New residential household seems to consist of a young woman living by herself. She's 19. And then it sort of indicates that she's actually the sort of daughter of a deceased male, Zhao Wenru, apparently living by herself. Then we have a new household. This is a healthy adult male, and he's 49 years old. And we would have to go back and find out whether what his relationship was to Zhao Wanfa. We could probably locate that in an earlier register. And then his wife, their son, then a new household. 23-year-old head. This person's name is Da Xiao, Big Little, born in the year of the tiger. His wife, his paternal grandmother, who was 74 but has passed away. And then his mother, who's still alive, she's 44. His wife, 23. So because of the importance of seniority, so basically in the register, the sort of members of sort of more senior people that were senior to the head, his parents and grandparents were listed ahead of his wife. Then we have his younger brother, and then let's see, this would be I think his uncle, the head's uncle, uncle's wife, and then a daughter. And then a new household, where the head of this household actually is listed as having escaped without permission, and then the son of that household head, and then that son's wife, surnamed Liu. Now here's the same set of people with some entrances and exits 3 years later in 1819. So they're, the rightmost column, they're still in the Daoitun administrative area. Second-most rightmost column, they're still in the plain yellow banner and Daoi. And then you have many of the same people listed in the same order, but typically 3 years older. What to pay attention to is here, we have 3 people in the left half of the page that have died since 1816. So the wife of a household head, she was 45. That's the first red box on the right. And then then going to the next household, a head and his grandmother have both passed away. The head that died, Da Xiao, he was 26, and his grandmother was 77. And then his mother, that's a case where I think there's some cases where somebody's death record is repeated. That's fairly easy to deal with in the software, and we do deal with that. And then we have a new arrival outlined in gray. The son of, in fact, this would be the son of that gentleman who died, Mr. Da Xiao, even though he passed away, his wife is still alive, and they apparently, before he died, he sort of fathered a son who is now 3 years old. Now it's important to note here, it's a property of the data, that obviously we have the son's current age at the time of the register, 1819, so we can infer from that the fact that the son was 3 years old, that the son was actually born in, 3 sui old. The son was actually born in 1817. So people in the calendar were 1 sui at the time of birth, and then they sort of increased by 1 sui every Chinese New Year. So we would be able to infer that, for example, that the wife was, say, now she's 26, but she would have been 24 when she had their son. And then, so this is an example of how things change, and a comparison with the preceding slide for 1860, the same people in 1816 should give some intuition about how we infer or understand the sort of change over time by comparison of the registers. That we have records of people as they die, so that we can go back and know that in 1816 these people were going to die between 1816 and 1813. This raises the question, obviously, of missing registers and how we deal with them. The registers annotate exits, and so deaths and so forth are annotated in the registers. And when we have these annotations, those are the basis of created flag variables that can be sort of put into the previous register that indicate whether or not people will experience some event between that register and the current event register. So if somebody's annotated as dead in 1819, we'll have a flag variable used for event history analysis that in 1816 indicates that this person will die between 1816 and 1819. Generally, event history analysis is prospective. You look at sort of people's current or past characteristics as predictors of what they will experience in the future. You run into problems if your outcome measure is also a indicator that something has occurred in the past, especially in these data, because actually, especially if the household head dies, that will change the relationships, recorded relationships of everyone in the household, and so forth. So it's just easier to do the analysis, basically looking at current past characteristics as predictors of events that will occur in the future. So, for example, in 1816, the chances that somebody will die before they reach the year 1819. Now, some registers are missing, and therefore for some people we won't have a recorded exit. We have people that simply disappear from one register to the next. We have created variables to indicate whether someone will disappear between the current register and the next. So anyone who wants can actually do that analysis to look at the predictors of disappearances. In fact, very, very few people actually disappear in adjacent surviving registers. It just doesn't happen very often. Almost all disappearances are attributable to the fact that we have missing registers. So, for example, if we had 1804 and 1810 but not 1807, somebody dies in their death is recorded in 1807, we don't have that register, that person will simply disappear between 1804 and 1810. This is not that serious of a problem because we can treat, say, that year in which they last appeared, 1804, as a censoring date and then just exclude them from further consideration. But this is why most of our event history analysis restrict to registers where the next triennial register is also available. The flag variables are available to identify the relevant observations. So most of the time when we carry out an event history analysis, we only use the register where the next succeeding triennial register is also available. So for example, we'd use, in this example of Dawi, 1816 would certainly be included. In fact, because we have Dawi 1822, 1819 would also be included, and so forth. And we would exclude registers where that were followed by a missing register. To go from the raw data to Excel spreadsheets, the coders transcribe the registers. Again, the most time-consuming register is always the first register in a series for an administrative population because that had to be transcribed from scratch. The remaining registers were always faster. The coders would just copy over the spreadsheet for the current register, add 3 to the year, and then as a first pass, add 3 to all of the ages, and then update the contents of the new register according to what was actually in the raw material. Again, the general principle was to transcribe the original data as exactly as possible. Obviously, if the inspection of the original data revealed an inconsistency in the age, where even though somebody's age should have increased by 3, it increased by 4 or only 2, the coders changed the age to resemble the original data. They didn't try to, quote, fix it. Also, almost all recoding, categorization, etc. was left for the software. As much as possible, we tried not to ask coders to make complex decisions or rely on their own judgment. So rather than categorize, say, occupations, we had them assign code numbers to each new occupation, and then we did recoding of occupations or categorization later on. The most intensive or I think intellectually demanding part of the data entry process was the relationship coding. So the relationships in the original registers each described a sort of unique relationship to the household head, but those had to be translated into strings that following guidelines. So this was fairly straightforward because, again, the relationships were recorded with such precision that everybody had a distinct known relationship to the head. We never had overlapping or duplicate relationships, except in some cases where, very rare cases, where some maybe small number of men married twice and they might have 2 wives. But even though in those cases we distinguished between the sort of primary and later wives with some detail. Now the names were written in Hanyu Pinyin. This was mainly, one reason was that way back when computers didn't handle Chinese characters very well, there were sort of lots of different character sets, Guobiao, Big Five, etc. It would have substantially complicated the process of doing the data entry, and we were also afraid of locking ourselves into a particular sort of character set that might eventually become non-standard or and so forth. There was a lot of trouble moving, say, Chinese character files from one computer to another. So we just sort of coded everything in Hanyu Pinyin. In many ways, this made things easier because it turned out that, especially in a pre-industrial population like this, there were a lot of cases where people who obviously had the same name in successive registers, that name was written with different characters that were homonyms. This may have been clerical error. It might have been this person's own, fault in terms of what they were reporting. They may have just changed the characters they used but kept the sound of their name. But one way or the other, just linking and searching based on Hanyu Pinyin turned out to be a lot easier than worrying about Chinese characters. I think a lot of the linkage and searching, because of these inconsistencies, we would have had to convert everything to Hanyu Pinyin anyway. Now, as I mentioned, when we had villages, official positions, official titles, actually disabilities, then the coders assigned numeric codes to every new sort of village or official position or title or disability that they saw, and then recorded the numbers, these codes, and their original content in separate code books for later processing. So again, we did not attempt to have the coders do any recategorization or classification of official positions or disabilities. Rather, they just essentially coded things as they were, and then all recoding was done later. And then for different purposes, for different analyses, we have the flexibility because we have the data, sort of the raw data coded. It's easy to sort of carry out different kinds of recoding. Probably if we were starting over, looking back, if we were doing data entry all over, we'd probably use a facility in Excel or purpose, or even maybe access to have input screens that restrict the contents of fields to particular types. But what we did here seemed to work well enough for our purposes, so that's the way it is. For longitudinal linkage, I want to review some of the procedures there. Again, households and individuals were listed in roughly the same order in successive registers. There are a few cases where households and individuals shifted from one register to the next. Those were fairly easy for the coders to track down. They could search based on name. If somebody seemed out of order and they needed to find them in the preceding register, it's fairly straightforward to do a search on their opinion for their name to find them. And so linkage was again fairly straightforward. Then the linkage was carried out because the ordering was so consistent that once we had the first register in a series coded, then we just transcribed the next one by copying it over and updating it. In every register, once the register was complete, the record numbers were sort of numbered from 1. So say after perhaps the 1816 register was complete, we'd renumber the records starting from 1. And then when they copied the file over to produce the next register, for example 1819, those record numbers from 1816 would go into the field that was used for the link identifiers. So they would link from 1819 back to a record in 1816, and then 1819 or whatever the next register was would be transcribed. People would be deleted if they had no longer there. They'd be inserted if they appeared for the first time. And then when 1819 was complete, with all those additions and deletions, its record numbers would be renumbered from 1, but we'd still have the link field that had the record numbers copied over from 1816. Those would be the basis of the link. And then once we wanted to carry out longitudinal linkage, we wrote software in Stata that basically would iterate through basically a series of merge commands, bring in sort of registers from the past, linking to them based on those link identifiers, and essentially iterate through again, merging and merging and merging until we'd reach the sort of first record for everybody. And then we'd assign a common identifier that would identify all of the records for a person. So here's a example of a spreadsheet from 1816 from those samples that I showed earlier from Dowie. So every row corresponds to a single observation. The leftmost column A is the case numbers that are assigned once the entry is complete. So notice that actually all these variable names in many cases don't have anything to do with the variable names you see in the CMGPD-LN release. A lot of these variable names were decided on back in the 1980s, and it was rather than go back and change them in all the spreadsheets, we left them all as is, and then in the process of creating the data files, we just rename everything. So again, these variable names at the tops from the spreadsheets, again, they are sort of outdated. So case eventually became record number, date became year, and so forth. RH head became relationship. Clan, obviously a very outmoded name. That's actually an identifier for EHU. That within each register, the first EHU would be 1, next EHU would be 2, and they'd be numbered sequentially through the rest of the register. Within each EHU, households would be identified sequentially 1, 2, 3, 4, 5, 6, and so forth. EHU is just a variable indicating the appearance of a new EHU. Address is a numeric code assigned by the coder for village name, sex 1 or 2 according to whether male or female or male. Generation we don't really use very often. That was early on. That was probably the only manually assigned sort of complex variable, which was generation was 3 if people were in the same generation as the head, 2 if they were the generation above, etc. Rank and occupation were numeric codes for titles and positions. Became the basis for the position variables in the public release after a lot of processing. Marital status assigned by the coders. This is actually something also that they did as a sort of a judgment call. 1 meaning currently married. That was based on the fact that they observed a spouse for that person in the register. 2 if this person was never married. And then 3 for a widowed. And then 4 for remarried. And again, those were inferred by the coders. We'll probably come back to that when we talk about marital status. So in the very earliest registers, first available registers, it's possible that some of the people that the coders inferred as having never been married, maybe they were married at some point in the past, but there was no register in which that marriage was recorded, so they would appear as never married. Or rather than say widowed or currently married. Or some people, might be listed as married for the first time, when in fact, if they're at some previous point in time before the registers are available, they might actually have been married. But again, we have no data to indicate that. Going further to the right, we have the name in pinyin. We have the vital events based on the annotations, or in some cases inferred. So annotations in the register generally include specify exits. 1 was a death, gu. 4 was a illegal departure, tao ding. And then 7 was an entrance, was actually inferred when a woman married in. This is just from the same group of people in 1819. You can look at how they've changed. I'm not going to go into this in too much detail. Basically the same people with some entrances and exits. Case has been renumbered. We don't have the link identifier here. Several people have been, if you look at column R, woman is married in Liu. There's newly recorded daughters. So it's important to note, and we'll come back to this, the births. So in the register that in which a person first appears, they're coded, as a 6 for sort of being born. But then when we actually do analysis, that the actual birth is sort of attributed or calculated for the sort of calculated year of birth, and then we use the variables are based on sort of calculated years of birth, not years of first appearance in the register. Now here is a comparison of 1816 and 1819 to give some sense of how the linking works. So you notice that in both registers the field case, which record number, has been numbered from 1. So again, once 1816 is complete, we sweep through and renumber case starting from 1. When 1819 was complete, it was renumbered. The case was renumbered starting from 1. But 1819 was when 1819 was initially generated, what we do is, in going from 1816 to 1819, we copy over 1816, and then what is case in 1816 gets copied over to column AB, L case, in 1819, and is preserved there as this person's sort of record in the preceding register. And then the date 1816 is copied over as well, becomes L date. And so you have 1, 2, 3, etc. Then for people that are newly appear for the first time, they don't exist in the previous register. Their L case and L date in AB and AC are just set to 0, and so forth. So we have basically, for all of the people that were apparent or present in the previous register, we have a link back to their record in the preceding register. That field ID, actually that's quite old. It's been superseded by work that was done in Stata, but that's a unique identifier that's based on concatenating these links based on date and L date. And sort of a single value of ID identifies the records of a person across different registers. Then we have inferred events. So as I mentioned, many exits are actually recorded directly in the data, deaths, outmarriages, and so forth. But then many entrances are actually inferred by comparison across registers. Basically, somebody is not in one register, but then they appear for the first time in the next register. Then we basically treat that as an entrance. So male marriage or remarriage was inferred by the new appearance of a wife. Female marriage was obviously inferred by the fact that a woman was there as a wife when she had not been there previously. Widowhood was inferred by the annotation of a wife or a husband as having died, or if if a register was missing, the disappearance of a wife or a husband. And in some cases, if we're missing a whole series of registers, maybe several consecutive registers, it's possible that a man might have, say, married and then lost his wife during those missing registers, in which case we would have no information either about the fact that he had married or had been widowed. And when the series resumes, he just would appear to be never married. We think those cases are fairly rare. Birth was inferred for the purpose of creating variables for analysis by working backward from the recorded age of a child the first time that they appeared in the register. So if a child first appeared in 1804 and at that time was listed as 6 Sway, means they were born in 1799. They would have been 1 Sway in 1799. 1800 they would have been 2 Sway, and so forth up to 1804 they would have been 6 Sway. So in an analysis like for variables like next boys or next girls, the relevant variable would have been set to 1 for the parent back in 1798, because they would have had their birth between 1798 and 1801. So because the birth was in 1799. So again, when we do the variables that refer to say births between the current register and the next register, again, are based on calculated years of birth, and then they're attributed to the register in which the preceding the year in which the child would have been born. They're not fertility calculations are not based on the year of the child's first appearance, because obviously in many cases children didn't get listed in the registers till they were 4 or 5 or 6 years old. Migration within the region was inferred by a change in the recorded village of residence for a household. The timing of the attainment of an official position or title or status was inferred from being newly annotated as having one. And then we have flag variables that are created in the CMGPD-LN that indicate whether an inferred event takes place between the current register and the next one, and typically is a 0-1. And those become the basis of event history analysis. Again, the way the analysis is typically carried out is that if, say, somebody is newly married as of 1801, the variable that we're interested in for analysis is set to 1, say the variable would be next marry in 1798, indicating that between 1798 and 1801 that this person would get married. Again, reflecting the fact that event history analysis should be forward-looking, looking at the influence of current and previous characteristics on the probability of an event occurring in the next typically 3 years. Now, it's appropriate to talk a little bit about inferred events and missing registers, these inferred entrances. So when a register is missing, we can obviously still infer that a event has occurred because somebody has appeared in the period between the two surviving registers, but we only know we can only locate the occurrence of that entrance in the possibly long period between those two surviving registers. So, for example, if 1801 and 1807 both survive, 1804 is missing, we see that somebody in 1807 has a wife, but they didn't have one in 1801. We know that they married between 1801 and 1807, but we only know that that marriage took place sometime during those 6 years. If 1804 was available, we could narrow it to within 3 years. Now, if several registers in a row are missing, it's possible that some events may be missed completely. So if, say, we have 4 registers in a row all missing, and a man marries in a register, say the first register that's missing, and then his wife passes away 2 or 3 registers later, and all of those registers in which he appeared are all missing, we'll simply have no record of that man's marriage. And that's, we haven't really, we've assumed that this is not that serious a problem, but this is why we, when we do event history analysis, including the ones for inferred events, we restrict to registers where the next triennial register is also available. You could use longer gaps, and we've experimented with that, 6-9 year gaps, and it may still work. It's just that you have to make sort of more assumptions about what may be going on during that interval. And we've generally, because there's so much data, we haven't really needed to cut corners by going beyond, say, the 3 year gaps. And here's an example of what the data look like when they finally get from the spreadsheet and that you saw earlier into the final public release data set. So here are some of the same people as you saw earlier from Dowie in 1816. The sort of case number, the variable case, has been turned into register sequence, which locates people within their register. We have relationship, that is what used to be the RH head. Age and sway is obviously the previous age variable. Next die is a constructed variable that indicates whether in, say, 1819 this person is listed as dying. So it's an indicator of whether this person dies in the next 3 years. At-risk die is a constructed flag that indicates that this is somebody that this observation is one that you would normally include in an analysis of mortality because this person is alive in the current register. And then the register from 3 years later is also available. We also have the missing values set appropriately now. Minus 98 is a sort of structural missing. Basically, this row 33533, register sequence 900, this father's mother was that maternal grandmother who had passed away. So she was already dead in 1816, so she was not obviously at risk of, well, she couldn't die again between 1816 and 1819, and she should not, was not at risk of dying. And here are the same people 3 years later in the CMGPD-LN. Not much new here. Same fields. Again, the people that have died as of 1819. These event variables have been set to -98 because they're not at risk of experiencing another death between or anything else between 1819 and 1822.